Okay guys, today we're going to review the idea of logarithms. So before we do that, we have to kind of backtrack a little bit. So first thing we have to talk, so we're going to talk about logarithms. Logarithms. Most of you sat through a class last year on logarithms. Just follow. Once again, you're not. Yeah, we're going to move through. We're going to talk about the rules, but let's see. So, and then, okay. So, let's backtrack a little bit. So, last year, we talked about domain and range, and that was simply the x values and the y values. And what we did was, we picked a bunch of domain values, and we plugged it in to some rule, and that got us our y value. So, for example, let's say the rule was like 2x plus 1. 2x plus 1. So, we plugged the 1 into the rule, and we did 2 times 1 plus 1 is 3. 1 went to 3. And 2 went to 5, right? Because 2 times 2 is 4 plus 1 is 5. And 3 went to 7. And 4 went to 9. That was the whole thing. And so, we plotted the points, we made lines, we thought about the lines, we analyzed them, all that stuff. But the idea was we took a bunch of x values and we used a rule to turn them into y values. And we did that with a couple of things. Let's do another one. How about 1, 2, 3, 4? Let's use the rule y equals x squared. And so the question is, how does the rule map 1, 2, 3, 4 into the range? And you'd say, okay, that's no big deal. 1 squared is 1. And 2 squared is 4, and 3 squared is 9, and 4 squared, this is a 4, squared is 16. And sometimes they were really basic, and other times they were a little more, advanced. So for example, you might get this rule. You might say y equals, x, x plus 5 over 2x minus 3. And so, one thing, you started with your 1, 2, 3, 4, and you plug the numbers in, and you said, okay, on the numerator, it's 1 plus 5, that's 6. In the denominator, it's 2 minus 3, negative 1, so it goes to negative 6. You looked at 2 and you plugged that in. 2 plus 5 is 7, and 4 minus 3 is 1. Not so bad. You looked at 3, and you plugged 3 into the rule. 8 over 6 minus 3, 8 thirds. And the last number, 4, 4 plus 5 is 9, and 8 minus 3 is 5. So 9 fifths. Okay. Now, we did all that, and then the next topic, one of the topics with functions, was something called the inverse. The inverse, and the idea behind the inverse is very simple. It was said, if there's a rule that can take 1, 2, 3, 4 to 3, 5, 7, 9, is there a rule, what's the rule that takes 3, 5, 7, 9 back to 1, 2, 3, 4? How do we get it back? Does anyone recall the technique? The technique was write the function, write the rule, switch the x and the y, and then make y the subject, or solve for y. So x minus 1 divided by 2 equals y. So the inverse, x minus 1 over 2 is the inverse, or actually these were inverses of each other. We're going to be talking about the inverse in another couple of chapters, and you're not responsible for this now, but let's see what happens when I put 3 in here. 3 minus 1 divided by 2, takes me back to 1. 5 minus 1, 4 divided by 2, back to 2. 7 minus 1, 6 over 2, back to 3. And 9 minus 1, which is 8 divided by 2, that takes me back to 4. So these are inverse functions. This is what's going on. How do we undo a square root, a square? Well, might say, same idea. Write down the equation, switch the variables, and then solve for y. This is supposed to be plus or minus, but I'm just making it positive. Okay, and that's the idea of the inverse. How do we undo squaring? We take the square root. What's the square root of 1? 1. What's the square root of 4? 2. What's the square root of 9? 3. What's the square root of 16? 4. This is the idea of the inverse. And you can kind of get some ideas about the inverse. You know, what's the inverse? What is the inverse of addition? You say, oh, subtraction. What is the inverse of multiplication? Division. What's the inverse of, like, squaring? Oh, the square root, and so on and so forth. And then the question was, what takes us back here? And it was a more complicated thing. You know, we'll talk about when we do inverses. So that's fine. And it was really great because we could take lines to lines and quadratics to radicals, and these are known as rational functions. We can find that. That's fine. Then, I'm getting to my point of what logarithms is. So then we got to this last point. We said, okay, same idea. 1, 2, 3, 4. And we introduced exponential functions. And we said, that's easy, right? That was easy enough, right? We said, so 2 to the first power is 2. And 2 to the second power is 4. 2 to the third power is 8. And, you know, 2 to the fourth power is 16. And we studied exponents, and we know exponents most of the time take small numbers and make them really, really large numbers. And so the question is, what is the inverse? You know, what is the inverse of y equals 2 to the x, or what is the inverse of exponentials? And once again, addition, subtraction, multiplication, division, we want an inverse for exponentials. And so you say, okay, Mr. Adler, based on the rules you told us, write the equation down, switch the x and the y, and you're left with this. Now, we always tell you in math, solve for y, but the problem is we can't solve for y. We don't have a technique for getting the y out of the exponent. So what we're going to do is we're going to create something called logarithms. We're going to say y equals log base 2 of x. And this new function, takes 2 back to 1. This new function takes 4 back to 2. It takes 8 back to 3 and 16 back to 4. And that's the idea of logarithms. Logarithms undo what exponents did. Now, if you remember, I told you to think about exponents using the word Ben. The guy's name Ben. So I said b to the e equals n. We're fixing the base. The idea with exponents is that an exponent goes to a number, right? With logarithms, the number is going to the exponent. That's the idea. In once again, in exponents, the exponent is going to the number. In logarithms, the number is going to the exponent. Right? That's the idea. So the first thing is, how do we transform between exponents and logarithms? Very simple. When you see log of 525 equals 2, that's like saying 5 squared equals 25. If 2 goes to 25, 25 goes to 2. That's the basic idea. Let's try another one. Log base 3, 9 equals 2. Again, once again, as an exponent, 3 squared equals 9. Log base 2 of 32 equals 5. And this is in logarithm. In exponents, 2 to the 5th equals 32. That's it. That's all it is. We're going to be talking about the rules in the next subunit, but right now we're just doing the intro to logs. So the question might be, write an exponential equation in logs. So you might see, okay, fine, 10 to the 3rd equals 1,000. So you'd say, okay, log base 10 of 1,000 is equal to 3. If the exponent with base 10 takes 3 to 1,000, then the logarithm of base 10 takes 1,000 to 3. That's it. That's all that's going on. You might get asked to, simplify. You might say, they might say log, base 5, let's see, 125, right? Now, we're going to do some rules here, but the idea is, when you see this, set it equal to x, and say, oh, you know what, use Ben, get it out of log world into exponential world, say, oh, 5 to the x equals 125. At this point, you should be like, oh, wait a minute, I know that that's 5 to the 3rd, x equals 3. Let me just find another problem. It might seem a little more complicated. They might say log, 8, 2. So you go, okay, well, I know this. Therefore, I know 8 to the something equals 2. So I know it's 2 to the 3x equals 2 to the 1st. X equals 1/3. That's it. Always go from logs into Ben. That's it. It'll make your life much easier. Then we start to discover, some rules. So you might say, wait a minute, Mr. Adler. If the log, so what's the log of b? B. What does that equal? Any suggestions? Well, you know what? Go into exponent world. B to what power? Give me b. Oh, wait a minute. That equals 1. Right? You might say, how about this one? Log of 5 of 1. You might say log of b times b to the x. So you might say, well, you know what? It looks like this problem over here. You might say, oh, wait a minute, Mr. Adler. This is 5 to the 3rd. Well, that was 3. Therefore, this is x. These are little rules you'll practice. If you're not really sure, so you see, if you're not really sure what is true, bring it back into exponent world. You'll always be fine. Just remember, so let's see, what are they saying here? And that's basically it. Yep. Yeah, you're fine. Let's try another one. That's basically it. That's what, once again, always go back to our rules. They have a couple of exercises where it's like 7 log of x plus 5 log of x, and that's simply 12 log of x. The last thing is just 2 little things. If you don't see a number down here, it's technically, this is called the common log, and it's base 10. If you see base e, like the last lesson, that's actually written as ln of x, and that's known as the natural log. Okay, so see what you can do with these.